artificial neural networks, I'll introduce you all to what is TensorFlow. Now, TensorFlow is one of the library which is widely, heavily used in deep learning, and it's nothing but it's same as we what we have learned in NumPy. You'll see through the examples it's the same, but the difference lies is that it has both models, advanced models, and it can deal with unstructured data. Like it can handle the data or like videos, images, and it can handle lots and lots of data, and it can leverage the use of GPUs, whereas NumPy limits itself to using CPUs and it consumes a lot of resources. So that is why you see a lot of places we have TensorFlow, and TensorFlow even has like variations. You can run TensorFlow in within the browser. You have a light version of TensorFlow that is for your mobile devices, and then you have the original version or the base version of TensorFlow. So I'll show you TensorFlow. What is TensorFlow? It's basically an open source and end-to-end platform. Like it's used for building ML models or deep learning models, and it makes use of Keras in the backend. Now, Keras is nothing. It's just another library, and it's used for building deep learning models, and it's widely used in the fields of computer vision and NLP. TensorFlow also have has an active community, and there's a lot of technical supports offered. So we'll move in how TensorFlow is implemented. So in order to implement like TensorFlow, we basically have three kinds of APIs that TensorFlow makes use of. So the first is the sequential API, and we'll be using this in our example. Now, this sequential API is a good API which can be used for things like image classification or regression tasks, and it can be used for it can be used basically for the classification and regression tasks, and when it comes to the advanced tasks like object detection and segmentation, we move to functional API. Now in sequential API, you write the code like this. You have you import from TensorFlow, you import Keras, and then you tell the layers, like you have these three layers, and you just pass in the layers to the sequential model. Now, coming to functional API, it's used for more advanced tasks where you have multiple inputs or you have multiple outputs, and you might need to skip some connections, and you have perform tasks like object detection or segmentation. So, for example, this is an example. You need to differentiate where the person is, where the kite is. You're detecting what the object is. So, for these kinds of tasks, we use functional API, and this is how it looks like implementing the functional API. So you declare X separately. In case of multiple X, you declare something like this. Then you have output separately, and then you connect both of them using the model function. Now there's another third API which is model subclassing, and it is used for implementing custom models, and you can control every step in the model building and training part. But like I'll not be covering it in detail. I've added this for the sake of completion, and this is like you can take a look how it looks, and you can read it about more because it's in like kind of advanced topic, and will mostly be dealing with sequential API. So coming to the basics of tensors. So in the TensorFlow, we call the array or the constant or a matrix all to be a tensor. So tensor is nothing but a number or a vector or a matrix. It's just a single word for all these three things. In NumPy we were calling it n-dimensional array, but in Tensor we call it like a tensor. Basically in TensorFlow we call it a tensor. Now, a tensor has following information. It has the shape of the tensor. It has the rank. So, rank is nothing, but if it's a constant, a single number, the rank is set to be 0. If it is a one-dimensional array, then we call the rank as 1. And if it is a two-dimensional array, we call the rank as 2, and so on. Then we have axis or dimension. So basically, if it's a 2D matrix, then the axis would be 2. It would have x-axis and y-axis. And then we have the size, that is the total number of items in the tensor. Now here I have told here whatever I told you, it is all written here as well. So now what we'll cover here is we'll start with creating a tensor. Now there are two ways to create a tensor. One is constant method, another is variable method. We'll see what is the difference between constant and variable as well. So now in constant method, you just import TensorFlow as TF. And TF is the globally used alias for using TensorFlow. And you pass in your number to tf.constant method. You print it, you see the type is tensor, which says what is the number. Shape is nothing because it's just a scalar quantity, constant, and you have the data type to be int. So it you see like I didn't specify the data type and it actually picked upon same. You can pass even a one-dimensional array. So if you pass in a one-dimensional array or a vector, you see it prints the that array. It prints the shape. Shape in one-dimensional array is the total number of elements in the array, and then it has this data type which is float. Similarly, you can even create a two-dimensional array, and you see the shape here is it has three rows and two columns, and it states the data type as well. Now you can access the dimension, like you can check the dimension by using ndim attribute. If you use the ndim attribute, you see for scalar we get 0, for vector we get 1, and for matrix we get 2. We can even create a tensor with 3 dimensions or 3D matrix. So here is like it's just simple. You just need to declare your matrix, and here you are. Like you have with this. We can cross verify by printing the indem. Now, if we want to convert a tensor into NumPy array, we have two methods, and it's really very simple. You just give in the tensor name, and then you use dot NumPy function, all dot NumPy method, and it's just converted. You've converted tensor into NumPy. Another way is that you use the function np array, and you just give in the TensorFlow name. So this is it. Like it's really very simple, and it's highly similar to NumPy array. Now, the tf.constant tensors which we have created using this method, they are immutable, like they cannot be modified and they cannot be changed. And while we are working with neural networks, you'll see that there is something called as weights, and we need to update them and we need to change them during a process called backpropagation. So we don't use this to create tensors in our examples. Rather, we use a tf dot variable method, which allows you to create mutable tensors, and we can even change the values. So it's all same, just you need to use variable here instead of constant. So here I've just added some examples. You can all go through it. And we can even convert the variable tensors into NumPy array. Now, similar to what we had in NumPy, like we had some built-in functions that would allow us to create NumPy arrays of ones or zeros or random values. We have similar such thing in tensors as well. So if you want to create a tensor that consists of only one, you can just specify the dimension, and you can use this once method. So here there is an example. Similarly, if you want to create a tensor which has only zeros, you can use tf.zeros method to create a tensor. You can also generate a tensor which has random values. Here I have set the seed to be true. If you change the seed value is set to be true. Even if you use the seed value and you create a tensor, you'll get the same values. If I change it to 4 and if I run it, you'll see that the values change. So it's just executing, it's taking some time, got executed. So see, now the values have changed completely. But if you run the same cell again, you will see it will have the same value. So now we can what we can do is we can like even shuffle the elements in the existing tensor. For example, we have created a tensor and it has the elements in this order. We can call dot random dot shuffle method, and we can pass in the tensor. And if we see this tensor, you see the items or like the numbers within this tensor have shuffled up. So 1 was here, but now 1 is here, and 4 was here, and it's shuffled up. Like you can use it for like again including randomization stuff. in your algorithms, and it's like used widely. Now, if we want to prevent this, we can use seed like set seed method, and again, it will always remain same. So every time if you run the shuffle tensor like this function with the seed value set, you'll see you get the same result every single time. Now, selecting the data, like we talked about indexing and slicing, it's all same as we have learned in NumPy. So I've just included an example, and I would request you all to go through it in detail. It's like really very simple. Just for printing it cleanly, I've converted it to .numpy. Even if you not use .numpy, you will get the result, and I'll show you just. It's not defined here. I'll exclude this and you'll see that it gets printed. But see, it has this df.tensor and all information. So just in order to cut it down, I've used .numpy method, and you'll see we can do perform indexing as well. So I'll share the link to this notebook as well, and it's all same. So I'm not repeating the stuff as I've already explained in a lot of detail in the session one itself on the day one. We can perform similar operations on tensors as we have learned in NumPy. For example, I can add a scalar value to the tensor. See, it was 1, 2, 3 here, and I've added 4, so it got incremented. I can even add two tensors using the plus symbol, or I can use the dot add method, dot multiply method. And what I would recommend you guys is that you go to the documentation of TensorFlow and then you see what are the other methods. Like you can implement divide, or you can implement subtract. And I would like you all can play with the code here in this notebook so that you get the more idea of TensorFlow and you get more familiar with the TensorFlow later. Now, as we learned about the reshape function in NumPy, similar to that, we have reshape function being offered by TensorFlow. Here you need to just pass in your example tensor and you need to give the dimensions in which you want to reshape, and you can just simply reshape the tensor as well. So this is it. It's the introduction of TensorFlow, and we use TensorFlow heavily in deep learning and in building neural networks.